Take a moment to examine a ticking clock and consider what someone else could be doing at the same time. Do you believe that time flows in the same way between you and the other person all of the time? You can answer that question by thinking about the theory of relativity and what it means for the idea of time. Let's begin with a few absolutes that we must accept. First and foremost, neither absolute motion nor absolute rest exist because objects move relative to each other. Imagine you were in a vehicle on your way to the Pilinya windmill. You are at rest for the person sitting next to you, but if you stand on the side of the road, you are moving at the same speed as the vehicle. But are those people on the roadside really standing still? The answer is no. Because the Earth is constantly in motion, the Sun is constantly in motion, and the galaxy is constantly in motion. Remember that the universe is expanding continually, hence everything within it moves continuously. Therefore, nothing is ever at absolute rest or absolute motion. Things just move relative to each other. Thus, you may be in motion relative to one individual, while at rest relative to another. Consequently, the speed of any object is relative and dependent on the frame of reference. The only constant is the speed of light. It stays constant regardless of the frame of reference. So we must agree that the speed of light for all observers is constant, therefore light is relative. But have you heard about time being relative? Consider a light beam between two mirrors. Let's duplicate this setup such that another light beam is being reflected between another set of mirrors. This time, the mirrors are reaching the speed of light. We can see that the light beam is traveling a longer distance with the help of the moving mirrors. Put a couple of individuals in this situation. Ron is within the fixed set of mirrors, while Kaiser is within the moving set of mirrors. Both Ron and Kaiser must travel at the same rate of light, and their light beams must strike the bottom mirror at the same instant. However, the range of Kaiser's light beam is greater. The only way it could work is if time slowed down for Kaiser. Observe how Kaiser's clock hand is moving much more slowly than Ron's. Time has slowed for Kaiser, allowing his light beam to go a greater distance. Speed is equal to distance divided by time. Therefore, Kaiser's distance is greater than Ron's when compared. Thus, the passing of time has slowed down for Kaiser. This is known as time dilation. Actually, this is a difficult idea to grasp since it seems to contradict our everyday experiences. But in order to understand relativity, you must stop thinking of time as a universally fixed unit, because the concept of time is relative. So it's important to keep in mind that the behavior of time can change. Depending on how rapidly you or another individual is accelerating, the time on your clock may not be the same as another's. And that time is not constant, because in relation to the velocity of a reference frame, time is relative.